Hey everyone, today we are going to graph a quadratic equation. Remember, the graph for a quadratic equation is called a parabola. And a parabola looks like a U, or it could look like an upside down UE also. How do you determine that? You come over here and you look at this equation y equals a times the quantity x minus h squared plus k. This is in what's called vertex form. And because it's in vertex form, we can learn a lot about this quadratic equation and what the graph's going to look like. So the A value tells you if the graph is going to open up like a regular U or down. So when I go over to our equation here in yellow, I have y equals -3 times the quantity. So this is our A value. And since A is negative, in our head right now, we should be thinking this graph has to open down, so it's going to be an upside down U. Now, what we also can learn from this equation is what the vertex is. So the vertex is HK. Now, I want you to notice something. I didn't put, see how in parentheses it's x minus h? That's written as a factor. That does not say x equals h. So you have to use the opposite sign. X minus h equals 0. If you add h to both sides, you get x equals h. So whatever the sign is in that parentheses, in the end, you're going to have to switch it. For the y value, it's just y equals k. So I did not change the value for k. So let's go on over to our equation here and find out what the vertex is. So when I look at this equation, first of all, does the graph open up or down? It opens down because A is negative. Now, what's the vertex? Remember, you look inside the parentheses, it's x minus 1. X minus 1 equals 0. So if I want to solve that for x, x would be positive 1. So it's going to be 1. And then y equals -2. So -2. So that's my vertex. All right, we're going to write that a little better here. 1, -2. So the next thing I want to do, I want to plot that point. So let's go ahead and plot it. Let me get a different color here. Let's go with blue. So 1, -2. So from the origin where the two lines intersect, remember this is x, this is y. Where they intersect, that's your origin. So we're going to go right 1 and down 2. And there is our vertex. Now, it wants to know if that vertex is at a maximum or minimum point. Because the graph is opening down, that vertex is the highest point. So it's going to have a maximum value. And that maximum value is always going to be the y of the vertex. So my maximum value here is -2. So the graph won't go any higher than -2 on the y-axis. Now, the axis of symmetry, we're going to draw a line right through this vertex, straight up and down, because the axis of symmetry is a vertical line. So here we go up, and here we go down. And remember, when you have a vertical line, that's a vux. And if you don't know what vux means, vux tells you you have a vertical line with a slope undefined, and it's the form x equals. So we have a vertical line, so it has to be x equals, and it's the x of the vertex. The x of the vertex is 1. So make sure when you write your axis of symmetry, you understand that it's a vertical line, and the equation for a vertical line is x equals. All right, so we got x equals 1 there. Now it says name 3 points on the graph. Well, why don't we figure out what the y-intercept is? To find the y-intercept, we make x 0. That's an easy point to find. So I'm going to just go over here a little bit, and I'm going to take my equation, and I'm going to put 0 in for x. When I do that, all I did was replace x with 0. That's the point I'm using. So when I put 0 in there, I get negative 3 times 0 minus 1, which is negative 1, squared minus 2. So I get negative 3. Negative 1 times negative 1 is 1, so times 1 minus 2. Negative 3 times 1 is negative 3 minus 2. I've got 3 negatives and 2 more negatives. That gives me 5 negatives. So 0, negative 5 will be on our graph. So again, I'm going to find a little brighter color for that. Let's go with this, 0, negative 5. So I'm going to go to this where the two lines intersect the origin. I'm going to go down 5. 1, 2, 3, 4, 5. Right there. And I'm going to put a dot. Now, because we know the axis of symmetry, that's where your parabola folds on top of one side. So take one side and fold it on top of the other. So if this point is 1 over from the axis of symmetry, there has to be another point on the other side 1 over. And that point is going to be 2, negative 5. So now we have 3 points because we also have the origin. The origin, or the vertex, excuse me, the vertex is 1, negative 2. So now we can draw our parabola. Make sure it's a U though, not a V, okay? Because if it's a V, it's going to be an absolute value. So just be careful when you draw this. All right? So think about what we did there. I probably could draw this out a little bit like that. All right, so now we have our parabola. And when I look at this, it's opening down. That's a good thing. We want to know the domain and range. Well, the domain is always, for every parabola, the domain is going to be infinity to negative infinity, no matter what. Easy points, those of you that are taking a quiz on this, whenever you're graphing a quadratic equation, the domain is negative infinity to infinity, because the domain is how far over it goes on the x-axis, and with these arrows here, it keeps going out and out and out and out. Now the range is how high and low it's going to go. Well, our highest point on the graph was negative 2, our maximum here. And the graph is going down from there. So our range is anything less than or equal to negative 2. Another way you could write that is from negative infinity to negative 2. And we're including the negative 2, so I have to put it in a bracket. Okay? Now, if I were to ask you what your x-intercepts are, the x-intercepts are where our graph crosses the x-axis. Does our graph cross the x-axis? No, so there aren't any. There's none on this drawing. The graph has to cross the x-axis to have x-intercepts. So, I hope you're good with that. I'm going to be doing some more of these as we go along. So if you need more videos on this, just watch. There's more coming. I hope you have an awesome day. Thank you. Do, 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 do.